Hello everybody, welcome back to the PDE's Blackstone series. And recall in the last video, we have substituted the second time, we have performed the second wave substitution. And we arrive here. Okay, we arrive at this chunk of the equation. Okay, so the next step is to remind us what's our goal in the first place. So if you go back and you look at our goal in the first place, this is what we want to reduce to, right? We just want partial f over partial b equal a constant times second partial f with respect to a. That's it. That's all we want for the left. So this is my idea. Okay, after getting all this, I'm gonna group it. Okay, so all right, so now I will group these into 4. Okay, so what is the 4th group? I'm gonna group these into, so I will grade coefficients. Okay, so basically it's just that number, that group times the coefficient. So the group's gonna be partial f with partial b and second partial f with respect to a. Also the first partial f with respect to a, and also just f. Okay, so recall, so for our purpose, this is the coefficient, this is the terms, the partial derivative we want to stay. Okay, so 1, 2 stay, and this one on the right hand side is the one we want to eliminate. So if you want to eliminate them, the coefficient bear these term bear partial f with respect to partial a and f have to be 0. Okay, so let's go ahead and group them. Okay, so if you group them, you should get something like this. So if you go back to this big chunk and you group, you should get partial f with respect to b times db over dt, right, plus partial square of f with respect to a times dA over ds, all that square, times s square over 2 plus partial f with respect to a times partial g with respect to a times dA over ds square times s square over g, okay, plus dA over ds times s plus dA square over ds square times s square over 2. Okay, and then you add f times partial g with respect to b times db over dt times 1 over g plus partial square of g with respect to a times dA over ds square times s square over 2g, okay, and then plus partial g with respect to a times d square over ds square times s square over 2g plus partial g over partial a times dA over ds times s over g minus 1 equal 0. Okay, this is after you do the grouping. Okay, so let me go ahead and do some highlights so you recognize it easier. So the one I highlight on yellow is the coefficient. The term. So this is partial f with respect to b. This is second partial f with respect to a. This is partial f with respect to a, and this is f. Okay, and what is the coefficient? The coefficient, let me go ahead and find blue. Let me see if it's clear. This is the coefficient for partial f with respect to b. Okay, this is the coefficient for... Actually, you know what? Let me try the... Oh, man. Okay, let me use the underline. I think it's better. So, okay, just want to make sure I got everything correct. This is the coefficient for partial f with respect to b. This one is the coefficient for partial f, second partial f with respect to a. These are the coefficient for partial f with respect to a. And these three, four are the coefficient of f. Okay, so you with me at this point? This is just basic grouping. Okay, so after you group, this is what's gonna happen. You go back to equation 3, right? Didn't mark it as 3. Oh, I don't have 3? Oh man, I didn't have 3. Let me go ahead and correct that. Okay, so I would say this is 3. Okay, so equation 3, you see it just have partial f with respect to b and second partial f with respect to a, right? So you at this stage, after you group all these, if you want 3 to appear, what you're gonna do, right? So in order for 3 to appear, 4 things have to happen. First of all, the coefficient of partial f, partial b, have to be equal to C1. The coefficient of partial f with respect to b is the first highlight. So first highlight equal to C1. Okay. Second thing gonna happen is the coefficient of partial square f, so a equal to negative C1. Okay, which is the second highlight. Oh, by the way, let me explain why. I make a mistake here. It's not C. I just want to reduce this to the best form. So just 1. Okay. So if you want this to happen, the reason why is this is gonna happen. This is the reason why I want coefficient of partial f with respect to b equals C1, and the coefficient of partial of f squared or a squared equal negative C1 is this. If you have something like this, C1 times partial f with respect to b times plus negative C1 times partial f squared with respect to a equals 0. If you solve them, you get partial f with respect to b minus partial f square f with respect to a square equals 0, and you get partial f with respect to b equal to partial square f equal second partial f with respect to a. This is what you're gonna get. This is exactly equation 3. Okay, this is the reason why I want the coefficient to equal to a constant C1, and the coefficient of the second partial f with respect to a equal to a negative constant C1. Okay, because when you add them up and equal to 0, they will equal to each other. Okay, cool. And also the next two things is what? The next two thing is the coefficient, of course, coefficient of partial f with respect to a equal to 0. Again, we want to eliminate it, right? So partial f with respect to a is the 3 highlight, red highlight equals 0. And lastly but not least, the coefficient of partial f, partial a, the coefficient of f equal to 0, which is the 4 underline equal to 0, red underline equals 0. Okay, so you have a system equation, and remember your goal is to find b and a. Okay, your goal is to find b and a, and if once you find a and b, you can get f and g. Okay, so let me remind the goal. Reminder. So the goal is to find a as a function ASBT, right? A is a function of s, b is a function of t, right? And after that, you can find f as a function of a and b, and g is a function of a and b. After that, you can find your v, okay? Because v is just f times g, okay? So ASBT, just want to make sure, is it ASBT? Yeah, ASBT. Okay, so what equation we have? So we have 4 equations, right? So what are these equations? Let me copy paste all of that down. So the first thing we have, the coefficient of partial f with respect to b equals c1, right? So the first equation we have is db over dt equal c1. I'll call this equation 4. Okay, and then you have dA over ds squared times s squared over 2 equal negative c1. I'll call this equation 5. Next one you're gonna have, because this is the coefficient of partial square f with respect to a square. Okay, the next equation you will have is partial g to a times dA over ds squared plus s times s squared over g plus dA over ds times s plus d squared over ds squared times s squared over 2 equals 0. I'll call this equation 6. And the next step you're gonna have is the coefficient of f equals 0, which is the longest coefficient in the world. So you have partial g with respect to b times db over dt times 1 over g plus second partial g with respect to g, so a times dA over ds squared times s squared over 2g plus partial g over partial a times squared a over ds squared times s squared over 2g plus partial of g with respect to a times dA over ds times s over g minus 1 equals 0. And I'll call this equation 7. Okay, so 4, 5, 6, 7. I think this is a good place to stop. To be honest, too much math. Let's go ahead and wash your face a bit and go to the restroom. In the next video, I'm going to solve these 4 equations and we can obtain a, b, f, g, and then finally v. Okay, thank you all for your attention, and I'll see you in the next video.